Today we're going to look at GibbsCAM for 3+2 milling, otherwise known as 5-axis indexing. Let's go ahead and get started. I'm going to go and read in a part. You'll notice that GibbsCAM can read in a variety of files. PTC Creo, Inventor, CATIA, just to name a few. So whatever format you have your part in, most likely we can read it in. But I'm going to pick Parasolid in this particular case. You'll notice that when this comes in, this particular part is really kind of arbitrarily positioned in space, really nothing orthogonal to any standard plane. So as a first step, let's go and get this part oriented correctly relative to the coordinate system. So first thing I do is to go and say let's go ahead and align this top face to the XY plane. If we get kind of a top-down view, you can see that it's still kind of skewed in 2D. We need to rotate this some. So I'm going to facilitate this, I'm going to go ahead and create a coordinate system. I'll call this left, and I want it to be a YZ kind of coordinate system. Now what I'm going to do is go ahead and align this side face to that plane. Again, shrink wrap the stock so that it lies completely around the part. Now the last thing I need to do is to change my origin. You can see it's here. I want it to be on this lower left corner here on top. So I will use the move part origin function for this. Now, I don't know what these values should be, so what I can do is I can use my shrink wrap values that it's already calculated for me to go and get the values. So I know I needed to move it in Y. I don't need to move it in X at all. I need to move it in Y, and I need to move it in Z. So I'm just going to use these values and plug those in, and you can see now that we have the coordinate system where we want it to be. So let's go ahead and get started with the actual machining process. I'm going to use a saved, what's called a saved process list here, and I'm going to pick the entire part and just let this start. Okay, so this is actually calculating right now, as you can see here. It's probably be a few minutes. Let me explain what's going on while it's going and generating these toolpaths. So this first one is a volume mill. Okay, so this is essentially a very high-speed roughing. You can see in this case we're machining aluminum 6061. We're going at about 400 inches per minute. Okay, so this is very specialized kind of roughing. There is something called the technology expert to help guide us through here so that it can calculate the feeds and speeds, the very high feeds and speeds that you need very accurately. Okay. The next thing we do, by the way, that volume mill leaves a little stock on the part. The next thing we do is some pocketing. You'll notice that we have three tools. The first tool was a 1-inch end mill. The second tool is a 1/2 inch. The third is a 1/4 inch. So the second process is done with a 1/2 inch mill. So it does pocketing, and what it does is clean up where the other one left off. So if I go to this tab here and see that I have rest milling checked on, so that's its clue that hey, you're going to go and you're only going to machine what the 1-inch end mill left behind. In the same sort of way, if I open up the third process, you can see that again rest milling is checked on. This is similar to the other process with one exception, that we're using a 1/4 inch end mill. So this third process is only going to clean up what the first one left behind, or second one left behind, rather. So these processes will probably run for about a minute more or so. I can't get a quick update on what's going on. So you can see that this is the volume mill process that's been done, and you can see this looks very different than traditional roughing processes in that, first of all, there are no sharp corners. And that's because we're running, again, at over 400 inches per minute, so you don't want to be your table to be taking a hard turn, right or left turn, when you're going that fast. It's just bad for the machine. So you also may notice that the toolpath goes down fully 1 inch, or actually not 1 inch, this is actually a little over 1.5 inches. So typically what you'll see is that the cuts will be twice the diameter of the tool itself. So it's a very efficient way to remove material. Okay? So we're just about done here. Give it just a few more seconds, and then we're going to move on. What we're going to do next, by the way, is you notice there's features here on the left, and that there's features here on the right. Okay, so we're going to go and apply these same processes to these features and to these features. Okay, one of the things we're going to need to do, by the way, while this is running, I can go ahead and go on and do other things. So one of the things I want to do is I want to adjust this left coordinate system so that the positive value where you see the plus is actually coincident with this plane. So the way I could do that is to change the origin, and all I want to do is change the D value, what's known as the depth value, and I want to set it to that. Go ahead and hit do it, and now that's complete. Okay, in the same sort of way, I'll make a coordinate system for the other side. Again, I'm just waiting for these other ops to finish, and I'll call it right. I'm not sure if I spelled that right. There we go. And what I'm going to do is, first of all, get the orientation right. So again, this is a YZ type orientation, and what I want to do now is change the origin, and all I'm really interested in, like before, is the D value. So I'm going to pick that up from the solid itself. Okay, and now I should have all of my coordinate systems complete. Okay, so I'll be ready to move on. We're just about there. This one's at 64% right now, so it should be done momentarily. But I've gone and set up my coordinate systems the way I want to. You also notice that we have color coding on, so I can actually see each toolpath in its own color. Okay, so the red is your volume mill, the yellow is the secondary op, and the blue is the tertiary third op. And so you can see how each one is only cleaning up what the other one left behind. And I think at this point you notice it now says 100%, so we're all done with that. Now let's go ahead and use what's called OpSim to see what we have here so far. So if I run my OpSim, and I'll just go ahead and set a few things up. I want the color to be the same as the op number. I want to turn on collision checking and error checking here as well. And let's go on and get the show on the road. So we can see the volume mill taking out large volumes of material here. And I'm going to speed things up here a little bit. Okay, good so far. Here's the second op, so we're going and only cleaning out what was left behind. I mentioned that left stock on the sides and the floor area, so you can see it cleaning out that stock. And now we see the third op, which is going in and essentially picking out the corners. Okay. All right, so that looks pretty good. Now another thing I can do at this point is I can check to see how well it's doing so far. So if I use this analyze cut part, I could go and hit this, and wherever I see light green, that's good. That means, hey, I'm comparing this cut model against a solid model, and wherever you see the light green, that means it's good. As I said, green means go, right? The blue is uncut virgin material, and the dark green is uncut non-virgin material. So we can see that we have these features on the side still left to do, as well as the whole operations. Okay, so let's go on and move on here at this point. As I mentioned, we want to go ahead and use these same processes for the other features on the other sides in our 3+2. So what I'm going to do is go and activate the left coordinate system, and then all I have to do is essentially three things. I have to adjust the z value. First of all, I have to make sure that it matches the coordinate system. So I go on and adjust that so it matches. Then I have to modify the z values for this particular one, and then I need to pick the geometry that I want to machine. So I'm going to turn on my face selection, and I'm going to pick faces above, and to unselect the few that I don't need. So this is what I'm interested in doing. Let me do one other thing. I'm going to adjust the chord height of this so the solid looks a little smoother. And now we're ready to go. So I'm using the same process, or I'm sorry, I've got to do that on all three processes. That is, I've got to adjust the z values on all three. So let me go and do that quickly. And one more to go. Great. Now I'm going to go ahead and say do it. It should go much faster in the first set since there's a lot less geometry to machine. Again, you can see the toolpaths color-coded there. We're all done. And what we're going to do is activate the third coordinate system, and the same sort of thing. Make sure that the coordinate system matches, adjust our z values, which in this case that's the same sort of pocket, so I really don't need to do that. And we should be good to go. After I pick the geometry, and again, same sort of philosophy. And now I'm going to say do it. Again, this should just take a few seconds to complete. And there's that. And we got one more feature to go here. So I already have adjusted the coordinate system. I don't need to change that, but I do need to change my z values here, right? So that will be good. Same sort of thing here. And one more. Okay. Now that I'm done, I could go on and just say, start here, pick the geometry I want and say do it. Again, this should take just a few seconds. Great. Okay. So now at this point, what I want to do is again to run an opsim on the. Actually, before I run an opsim on the entire part, let's do one other thing, which is that I want the tool changes to be minimized. Okay. So what I'm going to do is to go and say, I'm going to pick all of these ops, and I'm going to use something called the Operation Manager. This is kind of like a spreadsheet, and I can sort by anything. In this case, what I want to sort by is the tool number, which I've done here. Then I want to isolate all of tool 1. So these are all the tool 1 changes. And what I can do is say, let's move all of these to position number 1. In the same sort of way, I pick all of tool number 2 operations, and I want to move them all to 5. Continuing in this manner, pick all of 3. Actually, they're pretty much there, but I'm going to I'll make them sequential. So I'll do the same thing here. So now you'll see that in my operation list here, we have minimized the tool changes for what we see here. Okay. All right, now that I've done that, let's go on and do an opsim on this. And I'm going to speed things up here quite a bit. So you'll notice that now we're on op 5, which is tool 2. So tool 1 was only used in the first orientation apparently. Now we can see the orientation on the other features. And now we switch to tool 3, and we'll do the first setup first, again cleaning out those corners. By the way, I can also turn on my tool holder at any time if I like. Now you can see that we're cleaning out the corners in that feature. In this feature, we didn't need to do anything with the circular feature. And again, what I can do is to go ahead and analyze this as analyze the cut part. And we can see green just about everywhere except for the holes. So we see it there. If I swing around the other side, we see it there. That all looks good. Okay, so for the milling, we're essentially done here with this part. Okay, what we need to do now is to concentrate on the holes. Okay? So let me go ahead and I'm going to pick the entire solid, and we're going to use something called the hole manager. Okay, so the first thing I want to do when I'm doing the hole manager is to run AFR. That stands for automatic feature recognition. And you can see when I run that it's created these this specialized geometry, kind of a green X with a line and a horizontal line on the bottom. Okay, so what this means is that the X shows the top of the hole, the vertical line shows the center line of the hole, and this horizontal line shows on blind holes. That is, shows where the bottom of these holes are. So I know looking at this that these are all through holes. Okay, and now at this point I can pick and choose. I can check the orientations because sometimes a hole will be ambiguous, especially a through hole. It may not go the way I want, but everything looks pretty good in this case. But one thing I do want to do, bringing my hole manager back up, is I want to pick on this special geometry, and I want to get rid of this hole. Why? Because we've already milled that out, right? So that should really be the only hole that I want to modify or get rid of. So at this point, I'm going to do something called auto group and then auto whiz. So auto group sorts these holes by the size and the type, you know, whether it's blind, through, counterbore, countersunk, etc. You notice it also creates a whole bunch of tooling over here, right? So all that is done automatically, okay? So at this point, I should have everything I need. I want to check one other thing here. So one other thing you can do is you can set preferences here. And in this case, they all look pretty good. But in case I wanted to change things such as a master clearance plane or something like that, I could go ahead and do that there. So let's go and let's go now, and we're going to do the same sort of thing that you saw me do here before, which is we want to minimize for tool changes. Okay, so in the same sort of way, you know, I can go and say, let's go into the operation manager. And in this case, I'm only concerned with tool 4 forward. Why? Because we've already optimized the tool for tool changes on 1 through 3, right? So in the same sort of way, I just go and I say, okay, well, this one has to move to 13. Now tool 5 is just 1 op, so I'm not worried about that. Tool 6 is just 2. And I want to move those to number 20. Right? Tool 7 is by itself, tool 8 is by itself. I do not have to worry about them. Tool 9, let's move that to 24. And then tool 10 is the last one that we need to worry about. Let's move that up. Okay, so now we have gone ahead and optimized for tool changes. Okay, all right. Now, our whole op started on operation 13, as we see here, right? So what I'm going to do is go into OpSim once again, and I'm going to say that, hey, for now on, let's just start at operation number 13. So this, by doing this, what it does is I have to initially generate the stock one more time, but if I go in and I want to tweak certain things, I can go ahead and do that without having to wait for all of the milling to complete every time. So this is just a precaution in case that, again, I want to, something's wrong and I want to iterate a few times to, again, to tweak the toolpath to the desired state. Okay, so at this point it's waiting for me to go ahead and give it the command to move forward. So let's go ahead and do that. Okay, all right, so that looks pretty good here so far. Let me do one other thing here, which is exactly what we did before. Okay, let's go and look like this, and I see, you know, now light green where all the holes are. I go over this side, it all looks pretty good. The light green everywhere. So this gives me a warm, fuzzy feeling that, you know, everything has gone well so far. Now, there are a couple other things to consider. As I told you, it's gone ahead and created a bunch of tools here automatically for me. I can see, like in this particular one here, and that the flute length is kind of small, right? I anticipate that there's probably going to be some problems here with collision checking when I go to machine sim, which I'll show you here in just a second. But I just want to point out that this is only sticking a 1/4 inch out here at this point. Okay. So if I go into Machine Sim for the first time, this is the one that gives the, you can see we actually see the machine, and we actually see it running in the kinematics in the context of the machine itself, and we actually see the full machine, including features like this nozzle here and that sort of thing, okay? So this is the one that will catch any and all errors that may occur in collision, especially when this table, the C-axis, starts rotating around in space and it transitions between the various operations. Okay, in fact, here's one right here. See that? We took the little nick out of things. It's saying it's operation 6 between tool 2 and the stock, and in fact you can physically see that nick. What could possibly be causing this? Well, in a case like this, the first thing I look at is my what's called a master clearance plane, and it's only set at 7 here, right? So I'm going to bump it up to 9, And I don't need to regenerate the toolpath at all, right? But what I'll do here now is to go and say, let's go on and run this again. And let's see if we've cleared that first initial problem that we found here in the 3+2 environment. Good. Well, we've gotten past that error. So that's a really good sign. Let's see what else we come across here. Okay, so now all the milling's done. We did set up that started operation thing. So from now on, we won't have to wait for those milling operations to happen again. Let's just step through this since this is our first foray into this. And you can see that stubby little tool sticking out. Okay, so we're so far so good, but look at that right there. Okay, so you notice it's telling us a part of the spindle, which is this nozzle configuration, is actually hitting the stock here. So this stubbiness is going to have to go away. In fact, we're probably going to have to modify several tools to get around this issue, right? So that's what this is for. This is for finding errors such as that. So let's make, this tool. Let's say that it's sticking out 2 inches out of the holder here in this particular case. And quite frankly, we're probably going to have the same issues here with the next couple of tools. Any tools that machine here in the first setup, right? So let's go ahead and just to speed things up, anticipate some other errors here that may happen and just do some corrections ahead of time, okay? And to look at the remaining tools, so we have 7, 8, 9, 10, 11. Let's just look at those right now. So we do have potentially some of the errors, but some of these tools only come in on the side and there's a lot less clearance needed. So this is set at 0.75, as you can see. Let's just look. This is only 0.5. This may be a problem, but I'm just kind of reviewing everything. 0.75, 0.75. But again, all of these, I believe, are only coming out on the second setup. Okay, so let's go back into our machine sim. And let's notice it's because I set that start at operation 13. We don't have to wait through that milling again. You can see the tool, this tool on operation 13, which is tool 4, is much higher in, and we've already cleared that area. There was a problem before with that hitting. So let me go ahead and have it run by itself here for a little bit. I'll slow things down a little bit. So far, so good. We're up at operation 20 now. Operation 22. Okay, we do have a problem here. Again, notice that it's telling us it's tool 9 and it's against the stock. If I zoom up here, we can actually see the problem, right? That holder is hitting the stock, or the part rather. So I'm going to cancel here, and that again, remember, keep in mind that was tool 9, right? So if I go to tool 9, that was the extra stubby one. I'm going to go and give it, the same sort of length out of the holder as I did on the other ones. I don't have to modify the other ones, or at least I don't know about 10 or 11 yet, but this is the next one it had a problem with. So let's go back into our machine sim one more time, and I'm just going to have it generate quite quickly. And notice it says end of program here. So we're done. We passed all the collision checks, all the error checking. So the part is ready to go here at this point. So that concludes our demonstration of GibbsCAM for 3+2 milling, otherwise known as 5-axis indexing.